Alright, so let us start again. So we were talking about convolutions and filters. Now कोई व्हाट्सएप ग्रुप पे डाल दो भाई, क्लासेस स्टार्टेड. All right, so alright, so we were talking about, now this was a horizontal edge detector, okay, vertical edge detector, and this is a filter or a kernel. Now tell me, in real images, will you always have only horizontal edges and only vertical edges and horizontal edges? No. So in general, you may have to hand code this matrix. Anybody who has done image processing here? No? So then we just don't care. There are so many filters already known that have some special effects on the original image. Okay? So there are so many filters known already. So for example, there is this one, Sobel filter. So all these filters, they have some different use. We don't go into this. This is of concern to us. What is it? You see W1, W2 here. So what inference do I take from this? One, 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 0, 0, 0, minus 1, minus 1, minus 1. This was a vertical edge detector. Similarly, we had a horizontal edge detector. What does this mean? Let the network learn whatever filter it wants to use. Okay? So if the network wants to use a vertical edge detector, what will be the corresponding values of these guys? W1, W4, W7 will be 1, these guys will be 0, these guys will be minus 1, and so on. So we are saying don't fix the filter, rather let the network learn whatever filter it wants to use. And now this will make more sense. So what is this filter doing, for example? Can you give me, see, this looks like a horizontal edge detector somewhere, right? This looks like a vertical one. These are at some angles. This is recognizing just the white spot. This is recognizing just the black spot. And these are filters that are learning at various angles. What is an image, by the way? See, image, if you start image, this is a full image. But what is the least count? What is the least granularity to which you can take this image? A pixel? A pixel further divided into 3 intensities, right? You can't break it further. So for my neural network, what was the input? The input was these pixel values. What will be your output? Output will be somewhere here like yes or no. There is a car or there is no car, or whether there are objects and so on. So your output will be what are the contents of this image? Your input is the least granularity that you can have. if you directly try to answer high level questions about this image just by looking at pixels, it becomes difficult, right. So remember when I was saying you should not have input layer and then directly the output layer. What will be done by these hidden layers? You take these pixels, transform it to something which can be built by using pixels. Whatever you have here, transform it to something that can be built by using those things, and you keep on doing this so that finally you reach a image level thing. So maybe first hidden layer you are just learning filters, right, because filters are simple combinations of pixels. They are lines, they are blobs like this, simple things. You can reach here from pixels. Once you have these simple basic lines, you can make the next level complicated images from this. So something like this. Once you have these features, you can make things like faces now and keep on increasing, right. So every layer it complicates, or every layer basically takes input from the previous layer, learns how to combine them in a more broader fashion, in a more meaningful fashion, in a more fashion that makes sense to human eye, right. Human eye will not be able to make sense of this apart from edges. Human eye will not be able to make sense of pixels if they are given in raw form to them. So if you come from machine readable to human interpretable, right. So this gap you fill through these hidden layers. And now this will answer your question that why can't I directly go from just image to the classification saying yes or no. Nobody stops you from doing this, you can do this, but your accuracy will not be comparable to if you have a couple of hidden layers in between. Okay, so this is how people interpret output of computer vision problems. So from pixels you go to simple things that you can form using pixels, then you go to more complicated thing and so on. Any questions in here? And by the way, neural networks are just not interpretable. So these are just very tiny part that you can see what each layer is doing. So we have talked about this, we have talked about this, we were at this one now. Take convolution. So now I have a question for you. Maybe not right now. Padding, we have done padding. So padding, you just put a layer of zeros, and as rightly pointed out, your output will be n plus 2p minus f plus 1 cross n plus 2p minus f plus 1. Okay. This is done. Any questions here? We had a question. Why use padding? To? What does that mean? Yes. 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 So if you see here, the contribution of this filter, this particular pixel, is just once, right? If you take convolution of the original image, this will be contributing just to the first convolution, whereas this particular thing will be contributing to how many? 8 or 9? So 1, 2, 3, 9, maybe, whatever, but much more than 1. Okay. So it will be contributing to this one, then this one, then this one. Then it will also contribute to, so maybe 9, right. So this will be contributing to 9, whereas this will be contributing to 1. So there is a simple question, can I improve the representation of this guy? So you just take padding and now this will be there in many more convolutions compared to earlier ones. I don't think padding is that big a deal. I don't think it gives you that, that edge, but traditionally it is being done, so maybe it changes your accuracy by a couple of points in your decimals. I mean, it doesn't have much impact, but still we do it because in the end जब आप competitions की बात करते हो तो even 0.1 of accuracy will matter. So is this part fine? We have done it. Okay, now these are weird names that you will find everywhere. So when computer vision and NLP communities were growing, there were very few researchers working in this. It was not as hot as it is today. So you know what is a valid convolution? So valid is padding, same is padding. What is a valid padding? And what is same padding? So valid padding is the normal okay, the normal thing that we do. What is same padding? Pad such that output size is same as the input size. So for example, if we talk about this, right, 6 cross 6 was the original image, P is equal to 1 will give you 8 cross 8, you take convolution, that will give you 6 cross 6, is that right? 8 minus 3 plus 1, right? So what will be same padding in this case? P equal to 1. Pad so that output size is same as the input size, okay, and input size was 6 cross 6, P equal to 1 will make it 8 cross 8, convolve it with 3 cross 3 is going to give you 6 cross 6 again. Yes, see, names are weird, so you just have to remember them. Same padding means size of input should be same as the size of output, that's it. What is valid padding? No padding, n cross n, you take it with f cross f, you get n minus f and so on. Is this fine? Why do we do padding? Just one thing that we talked about, so it gives you more representation. There was one more reason, maybe I am forgetting that. So padding is over. Strided. So somebody said this final output will depend on the stride that you take. So you can again do this. Tell me, so input size is 7 cross 7, filter size is 3 cross 3. Now if you take stride of 2, you will take convolution with this one and then this one, and then finally this one. Similarly, here you will have this one, and so on. So what will be the output size? Output size will be 3 cross 3, and here is the formula. Okay. Earlier we had stride equal to 1, so this part was not there. Now you have stride equal to. Why do you see these floor functions there? So from whatever I know, this should have been plus 1 outside, but fine. Okay. There are times when it does not. Okay. Done. So stride is okay, straightforward thing. Instead of not skipping anything, you skip 1. What happens if stride is 0? Can you have stride equal to 0? No, because stride equal to 0 means fixed at that place, and that won't happen. Okay, and also it wouldn't make sense because it is dividing by 0. So stride is fine. What was the effect of stride, if anybody can help me? Stride is, if you see, it is drastically reducing the size of output layer, right? Stride equal to 2, can I say I will be roughly halving the size of the input image, roughly, right? It won't be exactly, but I will be roughly halving because I have n by 2 factor sitting here. Okay. So if you start with the image that is of size 1000 cross 1000, and if you take stride of 2, if you don't take stride, what will happen? 998 cross 998 if filter is 3 cross 3. But if you take stride of 2, it will be roughly 500 cross 500, right? So you have reduced the size of the image by 1/4 because it will be in the area, right? Only 1/4 will remain. So not half, actually 1/4, because half from here and half from here. How to?
Take call on what will be my stride.
We'll talk about that. So how to figure out whether you should have a stride or not, what should be convolution, what should be stride. As we have talked about these things before, all these things are hyperparameters and you decide them. So this is it. Okay. So we don't talk about this. For us, convolution is what we just talked about. Convolutions over volumes. So what does volume mean? I want you to help me out here. I don't have an image anymore. I don't have a black and white image anymore. I have a colored one. So this is R, this is G, this is B. So since black and white images are just one matrix, every element will be from 0 to 255. Colored images are 3 such sheets, and every number will be between 0 to 255. One will be for intensity of red, another one for green, and another one for blue. Okay, and you can actually store this in a different fashion. So it doesn't have to be RGB. Okay. Are you? No attendance. RGB. Okay. Now, How will you take convolutions in this case now? As we already know, deep learning is a jugaad, so you can do whatever jugaad you want. And so let me fix the dimensions. It is 6 cross 6 cross 3. So it's a volume now, it's not a area, it's a volume now. Yes. And then finally this third one here. Whatever you answer will be the right answer, right? So just throw something. How can I take convolutions in this case now? Earlier I had a 6 cross 6 image, filter was 3 cross 3. Now I have 6 cross 6 cross 3, filter should be 3 cross. Okay. So let's just do it. This is what you have: 6 cross 6 cross 3, 3 cross 3 cross 3. Now, okay, so here is, earlier when I had 6 cross 6 size image, filter size was 3 cross 3. Tell me how many multiplications are happening, how many additions are happening. When you had just 6 cross 6 and you convoluted it with 3 cross 3, how many multiplications happened? How many additions happened? Or how many multiplication, let's say, because complexity of multiplication is greater than the complexity of, greater than or equal to than the complexity of addition. भाई 2 मिनट यार, अभी तो आए हो तुम क्लास में. हाँ, yes. What will be the total number of multiplications? भाई for one element you are having 9 multiplications, and you have 16 such things. So 9 into 16. Is this number clear? Whatever it is, that's okay, right? So it will be basically output size cross filter size, I mean the number of elements in the filter. Is that fine? सोच लो एक बार, is this number okay with you? Output size is 4 cross 4. For every number I have multiplied these many numbers, so it is basically f cross the output size. Okay, as simple as that. In this case, in case of volumes, give me the total number of multiplications. One more thing, the course was very slow until now because we were covering basics. Now we will move at a very fast pace. I mean, as fast as I can do on board, but yes. Yes. So first of all you have to tell me what will be the output size, and that will tell you everything. See, it's a volume of size 3 cross 3 cross 3. Total how many numbers here? 27. 9, 9, 9. So 27 numbers here. I will have 27 number size volume here as well. Multiply all of them and add. So how many multiplications will be doing for first convolution? 27. How many numbers will be added? 27. Okay. And then you will get final one number here. So you multiply 27 numbers to get 1. So the total number of multiplications will be output size cross filter size. So that's a good question. Why is output not 3-dimensional? And can anybody help me make output 3-dimensional? Because this is jugaad, you are allowed to do whatever you want to. The only thing that is required is code it, show that it works better than the known techniques. That's it. Yes. Anybody? Can anybody help me get this? In which, see, whatever you say will be right. You just have to figure out a way. That's it. So instead of, if instead of this 3 cross 3 cross 3, I drop this one. I take a 2-dimensional 3 cross 3 filter, run it over this one, it will give me one layer of size 4 cross 4. Run it over the second one, it will give me another 4 cross 4. Run it over the third one, it will give me another 4 cross 4. That will give you 4 cross 4 cross 3. But it turns out this way of doing convolutions with volumes is better. So nobody stops you from taking that approach that I just said, but this one works better. So if you see here, how will you decide the filter size? Filter size is usually f cross f, and f is generally 3, 5, 7, 9, 11. This thing called NC, the number of channels, is decided by your image size. So if anybody in SIH, have you gone through ISRO problems? See, ISRO, if it's in ISRO's problem, you will generally see we have a data set of images of size n cross 64. Okay, so that means we don't just have RGB, we also have what is the altitude at that particular place, what is the temperature, dew, and so on. So 64 dimensions. Okay, if you were supposed to take a convolution of this image, what will be the filter size? It will be 3 cross 3 cross 64. So whatever you have as the third dimension, that fixes the third dimension in your filter. Write this down. At least this will be asked in the exam. I mean, this will be useful in the exam. कौन सा ट्रिम किया है? चलो. So again, the third dimension of my input fixes the third dimension of my filter. These two have to be same. Is it written by blood? You have to do it? No. But it turns out until today it is the best way to do it. Tomorrow somebody else can come and prove that they have a better method. Okay. So it does not matter what is your input size. Once you have decided a filter, your output will always be a 2-dimensional thing. So if you take n cross 64 with 3 cross 3 cross 64, that is going to give you, so if this is, let's say, 6 cross 6 cross 64, this is still going to give you a 4 cross 4. If you look at any computer vision code in PyTorch or in TensorFlow, there will be no code that you won't be able to understand if you are following this class. All you say there is conv 2D, stride, then pooling, will come to pooling, and so on. questions here. Is this part fine? So if this were 6 cross 6 cross 31, this will be f cross 31. This 31 is fixed. You can still make it 5 cross 5, right? You generally don't take f1 cross f2, but I said earlier nobody stops you from doing that either. Is this fine? So we go next. What is happening in this slide? Same thing that we just, right? Same thing that we just talked about. So at 6 cross 6 cross 3, when you take convolution with 3 cross 3 cross 3, is going to give you a 4 cross 4, and this everything we have just talked about.
There the filter of third one,
Yeah.
is 0, 0, 0, so it could be different.
Right. So because you have 3 different layers, all these 27 numbers can be different. So for example, for whatever reason network thinks for first layer I want to have a vertical filter and I want to have zeros here, it has the freedom to do so. So it is not like if this is 1 1 1 0 0 0 minus 1 minus 1 minus 1, that for all the 3 layers it will be the same. Then I don't really need this third dimension. So how many weights do you have in this case? In case a 2D image you had a 3 cross 3 filter. So how many parameters you could have? 9. In this case how many parameters you can have? 27. Because all these things, all these 9 numbers are independent of each other, they can take whatever value. If one is fixed, another one is not fixed. Okay, so now you will have to help me figure out. I know how do I get this 4 cross 4. I want to get 4 cross 4 cross 3 now. How do I do that? Filter? 10 मिनट तक रामायण गाई है मैंने कि ये 3 ही रहेगा. So we started like this, you can do whatever, and then we said you can't do whatever, this is fixed. So once this is fixed, you have to give me this third dimension. So okay, so just to help you out. So how will you give me 3 cross 3 cross? I mean 4 cross 4 cross 2. Neil. अब बताओ. Easy, you can give. एक और filter apply करो. Okay. So this was filter 1, let's say. Apply a filter 2. That will also give me a 4 cross 4 matrix. Just superimpose and what you have is 4 cross 4 cross 2. So if I have C filters, 4 cross 4 cross C. And this is what is happening here. So you have 2 filters, okay. First one take convolution, you get this thing. Second one take convolution and you get this thing. Put one layer over the other, you have 4 cross 4 cross 2. And remember, this will be same as this one and this one. Any questions here? You
फिल्टर क्रॉस है दोनों में सेम है जैसे 3 क्रॉस 3 तो रहेगा पर नीचे वाले में 5 क्रॉस 5 दे सकते हैं
you help me out. I don't know. So if this is 3 cross 3, can you take this 5 cross 5? So the answer is yes. But my question is, how will you handle this? You have one output of size. You have one output of size 4 cross 4. If this is 5 cross 5, this guy will be 6 minus 5 plus 1, 2 cross 2. So this is 4 cross 4, this is 2 cross 2. How do I handle this? And if you say padding kar do, makes sense, right? But so just do padding and get it 4 cross 4. This will be a right way to do it, okay? But people have tried so many different things. It turns out this will give you a worse network. So what you rather do is, right now when you are taking convolution for this layer, stick to this size 3 cross 3, and actually this is also fixed. So the only freedom that you can have is number of filters. So if you use 10 number of filters, my output size will be. So at this stage of your network, the only freedom that you have is number of filters, or you come up with a better idea and show that it works better than this one, right? So there is no closed thing, everything is open as long as you can show that your idea works better. Yes, you were saying something, Amit? Okay. These twos, so can these two have different parameters? They will, else there is no point of having two filters that are having the same parameters, okay? So the parameters here will be different. So now we come to a convolution layer. So this particular part, this is your image 6 cross 6 cross 3, two filters. First one will give you 4 cross 4, another one will give you 4 cross 4. Why different colors? Because they are different numbers, they have nothing to do with each other. So is there anything common in these two filters? No, these are two different filters, okay? So you take convolution with this, what you get is a 4 cross 4. You take convolution of this with this, what you get is 4 cross 4. These two numbers are not related. They may turn out to be the same, right? But they are not related. Okay. Now, you have plus B1. What is B1? Bias. You add this B1 to all these 4 cross 4. You add this B2 to all these 4 cross 4. Finally take ReLU of this, and what you get is your output of this convolution layer. Now we are coming back to the original things. What were they? First take the linear operation, then take a non-linearity. So somebody of you will have to help me figure out that convolution is a linear operation. Abhi nahi, whenever you can. Okay, so this is what we had originally, and we'll come back to this. Convolution network are feed forward neural networks. We can convert CNNs to deep neural networks and vice versa. They are one and the same thing, just different ways of representation. In the end, not today's class, but maybe tomorrow's or next class, will show that they are equivalent subject to some constraints. Any questions in this? Yes. So maybe I'll take a pause for 10 seconds. किसी को कुछ question पूछना हो तो? You are letting me go too fast, which is fine with me. Yes. What are these numbers here? Acha, tell me one thing. When you were doing wx plus b, what is this z? Constant? No. Z. So how do you compute z? Wx plus b. What is this z? Z is the output of applying this linear function to your input. Okay. So these matrices are nothing but linear output of your convolution neural network. So they are plain numbers. These are numbers, these are parameters, but since you are learning them, you will eventually initialize them to some numbers. So these are numbers, everything is a number. More questions here? As many weird questions as you can ask, because nothing is weird. Yes? Here you can't, so you don't really tell me, okay, this is a good question. So here you had 0 to 255 as inputs. After multiplying this, can I have a number here which goes beyond this limit 0 to 255? This is unbounded, right? What will be the output? This will be W1 x1, W2 x2. Just because these guys were confined between 0 to 255 does not mean that their multiplication will be. Multiplication and finally addition will be. Okay? And we have seen this before. We saw things like -8, -3 that were going beyond 0 to 255. They do carry, because in the end you use them to figure out something. See, we'll come to these things, right?
So like previously when we were doing it black and white, so we were as an output we were getting horizontal edges or vertical edges after applying the filter. So in this case, when we have the colors, then what will be the significance of the output we get?
So, as I said before, we started with something that we could interpret. So we started with a vertical edge detector, that this is what it does. But soon after that we said we don't want to fix or get confined to a vertical edge detector. I will keep parameters there. So whatever network learns. So it turns out we have very little idea of what goes inside a neural network. Okay. So when you want to say, I want to understand what is this filter, this may not always be possible. So let's say if all these values are 1 1 1 0 0 0 minus 1 minus 1 minus 1, then I can say it's a vertical edge detector. But if the numbers are such that they don't make sense to me, then as a human I am not able to interpret it, but machine knows how to make sense of those numbers. So machine never told me I took this filter and this is how it makes sense.
It will be an image, like in standard we apply a filter to an image.
Right.
It results in a similar images.
बिल्कुल. So as we have seen it here, so to some extent you will be able to do things like, so to some extent you will be able to do things like this. So these are nothing but filters only. So now if you want to plot filters, these are filters, right? So yes, in this case you can interpret, not always.
So like after few layers it will not be able to.
Exactly. So after few layers, because see right now this was initially just combination of a pixels. So you get these simple geometries from pixels. Later on when you will have filters of size, let's say 5 cross 5 cross 128. Now I have no idea what 5 cross 5 cross 128 might be doing. Any questions here? More questions here? So if I have 6 cross 6 cross 3 image size data set, I have 10,000 such images. I have 10 filters of size 3 cross 3 cross 3. And I want to take convolution and so on. Tell me how many parameters do I have in my network? Don't answer straightforward, but just raise your hands. Question is, I have 10,000 6 cross 6 cross 3 images in my training data set. I have 10 filters, each one of size 3 cross 3 cross 3. How many parameters do I have in my network? This is my most favorite question. There will be no exam जिसमें ये question नहीं आएगा कि what is the number of parameters in a given network. And this is what deep learning is all about, right? If you see, GPT-4 does not even tell what is the number of parameters. It does not give other information like architecture, training data and so on, but it does not even tell you the number. They could have simply said 1.5 trillion, whatever it is. But they did not even tell this because that also reveals a lot of information. Yes. 10,000 images of size this, 10 filters. What is the total number of parameters in this neural network? 270. So which information is totally redundant? 10K. I can have 10K, I can have 100K. My parameters don't depend on the training data size. Okay. Does it depend on the size of image? It does not. Okay. But in case of the normal feed forward neural networks, was it a deciding factor? You had x1 to xn, and the next layer, this cross this will actually give you the number of parameters. So this is a change now. Okay. 27 in one filter, you have 10 of them, 270. There is a bias corresponding to every filter. So plus 10, 270 plus 10, that gives you 280. क्या चीज? Say it again. This is your input feature. It's a good thing that it does not, because otherwise your CNN that you are designing for 6 cross 6 image will be very different from 1000 cross 1000 image. And if you remember, we started today's class at 9 AM by saying that the number of parameters really explode if I start using the normal feed forward neural networks with images. Having done everything, after that we will do equivalence, they both are the same. Fine? So quickly tell me what is the number of parameters in this net? Or maybe I'll make your life simple. I can't. So I can't make it simpler. You have to just tell me what is the total number of parameters in this. Tell me what could be P superscript 1 in square brackets? Padding in layer 1. What will be P2 in square brackets? Stride at layer 2, filter at layer 2. So you can already see filter at layer 1 can be different from filter at layer 2. So give me the total number of parameters in this now. You can also have different height and different width. In this case it is just 39. Okay. Yes. So see, filter here is, so F1 is 3, right? That means it is 3 cross 3, okay? 3 cross 3, how many of them? 10 of them. Who decides all these things? Who decides all these things? You. Okay. So I want to use a filter of size 3 cross 3. This will be the stride, this will be the padding, and these many number of filters. So first tell me, how do I go from here to here? Just tell me this one. How do we go from this input size to this output size? See, 39 cross 39 cross 3, what will be the filter size? 3 cross 3 cross 3. Why 3? Because this guy fixes it. So 3 cross 3 cross 3. How many parameters now? 3 cross 3 cross 3. 27 into 10. What else? Plus 10. So that gives me 10 into 3 cross 3 cross 3 plus, so basically plus 1. Okay. Strides, do they have parameters? No. Padding? No. These are hyperparameters though. Okay. How 37 cross 10? 39 minus 3, that gives 36, plus 1, that gives me 37 cross 30. Why this 10? 10 filters. So 10. Is this fine now? Total number of parameters in this layer is fine. You give me in this one. Does this give me parameter? Does these two things, they don't add to parameters. So what is my filter size? 5 cross 5 cross 10. Why 10? Because this fixes that 10. Now how many of them are there? That gives you the number of parameters in this layer. Finally, this one. So wait. How 17 cross 17? 37 minus 5, 32. There is no padding. Right. So by 2. So how 17? 32 by 2, 16 plus 1, that gives you 17. So this part is fine. Now you see, this number is comparable to this number, but is very half of this one. Okay. So stride really shrinks the output size. Now how many filters? 20. So 17 cross 17 cross 20 here. Is this the number of parameters, or am I making any mistake? Is this fine? I have your approval here? Fine. What about this guy? So 5 cross 20 plus 1, and then how many of them? 40. So how do you get this 7 cross 40? How do you get this 7 cross 40? Same formula, okay? Same formula, apply this and done. Why this 40? Because 40 filters. And then finally what you did here? 1960. You just flatten this whole cuboid. 7 cross 40 is 1960. Finally, in the end, if you see, it is good old logistic regression to say whether there is car or not. So this whole network is just trying to convert your car, your image, into these 1960 signature of that image, that is given as input to logistic regression and will give you yes or no. How many parameters here? You just flatten this, so 0 parameters. How many parameters here? 1960 plus 1. Sum them all and that will give you the total number of parameters in this network. So we are done for today. Attendance और रह गई यार.